In this video, we are going to be learning about how to use our data sheet to predict the solubility and colour of ionic compounds. So to do this, you will need to have your data sheet in front of you, and I'm going to ask you to stop and start the video regularly. So how do we determine if an ionic compound is soluble or insoluble in water? Well, in the laboratory, what you do is you add a small amount of that compound to water, stir it and see if it dissolves. Now, if it's soluble, then when you hold it up to the light, you can see through it. So when you look at these pictures here of different solutions, you can hold them up to the light and you can see through them. So all solutions are considered to be clear because you can see through them. This here would be a pink solution, but it's definitely clear because you can see through it. This is a green solution, but it's clear because you can see through it. Yellow solution and blue solution. So what happens when the ionic compound dissolves? Now, when it does dissolve, it dissociates. Now, what that means is that the ions in the ionic compound fall apart in the dissolving process. Now, how do we know this happens? We know this happens because solutions of ionic compounds can conduct electricity. So when we're not in the lab, how do we find out if they're soluble or insoluble? Well, you've been given a data sheet, and this data sheet has all the work of previous scientists who found out the solubility of these different ionic compounds. The first thing that you'll find is it's got two tables. The first table is a soluble in water table, and the second table is an insoluble in water table. The first table looks at everything that tends to be solid, which is soluble, which is most chlorides, bromides, iodides, all nitrates, all ethanoates, and most sulfates. And then it lists the exceptions. With the insoluble in water table, most hydroxides, carbonates, phosphates, and sulfides are insoluble, and these are the exceptions which are soluble. So, how do you work the table? You look at the anion. So the anion of sodium chloride is the chloride ion. You go to tables and you find, oh, there's most chlorides, and most chlorides are soluble, except for silver chloride and lead chloride. So our sodium chloride is soluble. Let's look at our second example, a bromide. And if we look here, most bromides are soluble. But silver bromide is insoluble because it's an exception. Look at the next one, calcium sulfate. So most sulfates, looking at the sulfates, are soluble, and calcium sulfate is slightly soluble. That means that at very, very low concentrations, it will dissolve in water. At higher concentrations, it will be insoluble. Let's look at the next example. It's a hydroxide. Going down the table, I find my hydroxides are here, and most hydroxides are insoluble. But if I look at this list, sodium hydroxide is an exception, and it is soluble. Next one is a carbonate. I go down my list, and I find most carbonates are insoluble. I check the exception list, it's not an exception, so it is insoluble. Let's look at our last example. It's an iodide. I go down my list, I find iodides are here. Most iodides are soluble, but this is on the exception list, so it is insoluble. So what happens when an ionic compound is soluble? They undergo what's called a dissociation process. This is where the particles, the ions in the ionic compound, fall apart or dissociate. They come apart through the dissolving process. So sodium chloride was soluble. This means that when it's put in water, the sodium chloride, which was a solid, breaks apart into sodium ions and chloride ions. And remember, we know this because these solutions will conduct electricity. Silver bromide was insoluble, so it has no dissociation equation because it stays stuck together. Sodium hydroxide was soluble, so it will dissociate to form sodium ions, which are aqueous, and hydroxide ions, which are aqueous. Calcium carbonate was insoluble, so it has no dissociation equation. Lead iodide was insoluble, no dissociation equation. Calcium nitrate is soluble. Now this is a bit tricky, watch carefully. We know that calcium nitrate is composed of calcium ions and 2 nitrate ions, and it breaks apart into its constituent ions. Chromium sulfate is soluble, so it will undergo dissociation. Look carefully. How many chromium ions are there? There are 2 chromium ions. How many sulfate ions are there? There were 3 sulfate ions. Now let's look at how to determine the colour. So on your data sheet, you'll find a section called Colours of Selected Substances. It states, in general, ionic solids have the same colour as that of any coloured ion they contain. So most solutions will have the same colour as their solid. 2 colourless ions usually produce a white solid, so white solids make colourless solutions. And there are selected exceptions to these basic rules as noted below. So the first thing we always check is our exceptions table, which is this one, and then we check the coloured ions in aqueous solution table. Now let's look at how we do this. Let's look at our first example. It is copper carbonate. So I always check my exceptions table first and then my coloured ions in solution. So copper carbonate, going down my exceptions table, is here, and you can see that it is green. My next one is cobalt chloride. Check the exceptions list first. So I'm going down the exceptions list and I see no cobalt chloride. Then I go over here. Because it's not on the exception, I can see it's got a pink ion, so this will be a pink solid and a pink solution. The next one I look at is sodium chloride. I'm going down my exception list, I see no sodium chloride, then I go down my coloured ions list, and it's not there. Now if it's not there, then it's a white solid and a colourless solution if it was dissolved. The next one, lead iodide. I go down my exception list and I'm looking for lead iodide. There it is. So it's an exception. So this will make a yellow solid. Next one, nickel nitrate. I go down my exception list. There's no nickels there. So I go down my coloured ions in solution list and there's nickel. So this will be a green solid and a green solution. Next one, calcium carbonate. Go down my exception list, then look at the coloured ions in aqueous solution. It's not there. So if it's not there, that means it's a white solid. And as calcium carbonate will not dissolve in water, you don't get a solution. Next one, copper sulfate. So I look down, I can see there's some coppers here, but there's no copper sulfate. I come over here and I find that copper ions were blue. So this will make a blue solid, and this is soluble in water, so and a blue solution. Now, I'm going to get you to try some for yourself. So you'll need to complete the table on your OneNote Chemistry Precipitate Reactions, and it's the first precipitate reaction sheet. Go right down to the bottom of the page. I've constructed a table for you. You're going to need to stop and start the video so that you can try your examples yourself and then check the answers. So the first one I'm going to get you to look up is sodium chloride. So stop the video and find out yourself. So sodium chloride is a white solid. It's soluble. So we have a dissociation equation. And you can see here that it is a colourless solution. Now we do not say that it is clear because all solutions are considered to be clear. Let's look at the next example. You are going to look at copper 2 carbonate. I need you to stop the video and find out the required information. So, copper 2 carbonate, colour of the solid is pink. It is insoluble in water, so it has no dissociation equation and it has no coloured solution because it doesn't dissolve. Next one you're going to find out is nickel 2 chloride. Stop the video and try it out. You can see that nickel 2 chloride is green solid. It is soluble in water, so it has a dissociation equation. Nickel 2 chloride solid goes to nickel ions plus 2 chloride ions, and you can see here the colour of the solution is green. Okay, now you're going to try copper 2 carbonate. Stop the video and try the example yourself. You can see here that copper 2 carbonate is a green solid. It is insoluble in water, so it has no dissociation equation, it has no coloured solution. Next one you're going to try is calcium phosphate. Stop the video and try it yourself. You can see calcium phosphate is a white solid. It is insoluble in water, so it has no dissociation equation and no coloured solution. Next example you're going to try is iron 2 chloride. Stop the video and check your data sheet and complete the table. You can see that iron 2 chloride is a pale green solid. It's soluble in water, so it has a dissociation equation. Remember, 2 chloride ions has to balance. And the colour of the solution is pale green. Next example you're doing is iron 3 chloride. Stop the video and complete the table. Iron 3 chloride is a brown solid. It's soluble in water, so the dissociation equation would be iron 3 chloride goes to iron 3 ions plus 3 chloride ions. This will give you a pale brown solution. Next example you're going to try is chromium 3 chloride. Stop the video and have a go. You can see here it is a deep green solid. It is soluble in water, so it dissociates to give you chromium 3 ions plus 3 chloride ions, and it gives you a deep green solution. Next example is lead 2 iodide. Stop the video and have a go. It gives a yellow solid and it's insoluble in water. So it has no dissociation equation and no coloured solution. Our next example is copper 2 sulfate. Stop the video and complete the table. So copper 2 sulfate is a blue solid. It's soluble in water, so it dissociates to give copper ions and sulfate ions, and it gives a blue solution. Next example is zinc chloride. Stop the video and complete the table. It's a white solid. It's soluble in water, so it dissociates and remember, it gives you a colourless solution because all solutions are clear. Next example is manganese 2 chloride. Stop the video and have a go. It gives a pale pink solid. It's soluble in water, so it dissociates to give manganese 2 ions plus 2 chloride ions, and it gives a pale pink solution. Next example is silver sulfide. Stop the video and have a go, and you can see it gives a black solid. It's insoluble in water, so it has no dissociation equation and no coloured solution. I hope you've got the hang of this. If not, go back and try some more examples.